Hi everyone, today we're going to be talking about divisibility results in other bases. So what we're trying to do today is figure out if we can find some tricks in all other bases past 10 and before 10 that are going to help us know right away that a number is going to be divisible by another number in that base. So the first divisibility trick that we can use is that every number in any base is going to be divisible by 1. So any number in any base is going to be divisible by 1. And this is something that we talk about in base 10 all the time, because any number when divided by 1, the answer is just going to be that number. So for example, if we have 32 base 4 divided by 1 in base 4, we know that our answer is going to be 32 base 4. And this is consistent throughout all bases, just as it is in base 10. Our second divisibility trick is going to be how to know when a number is divisible by 2. And the rule for this one is any even number, if you're working in an even base, is going to be divisible by 2. So again, any even number, when working in an even base, is divisible by 2. And we see this in base 10 because base 10 is an even base. We know that all even numbers in base 10 are also going to be divisible by 2. So an example of this is, say we have 12 base 8 divided by 2. We know that our answer is 6 in base 8. And we know that 12 is divisible by 2 because it's an even number, we're working in an even base, and then you get your answer in that same base. So again, any even number when the base is even is divisible by 2. So say we had an odd base. Let's just look at this for a second. Say we have 11 base 2 divided by, 11 base 3 divided by 2 base 3. That should have been base 3 up here as well. We don't know for sure that this number is going to be divisible by 2 because we're working in an odd base, and we have an odd number. So just remember that both the number and the base must be even if the number is going to be divisible by 2. We'll get rid of this, and we have 2 more tricks that we can use when we're working in other bases. So the next one is going to be how we know when a number is divisible by the base minus 1. And once we get to the example problems, this will be made a little bit more clear. But if we want to know if a number is divisible by the base minus 1, the digits will add to the base minus 1. but that's only going to last up to 10 in every base. So again, a number is divisible by the base minus 1 if the digits will add to the base minus 1, and this is going to work only up until 10 in each of our bases. So an example problem for this one is going to be if we have 26 base 9 divided by 8 in base 9, we can see that because 6 plus 2 is going to give us 8, so 2 plus 6 gives us 8, which is equal to base, our base, which is 9, minus 1, which also gives us 8. So we right away know that 26 is going to be 26 in base 9 is going to be divisible by 8 in base 9 because the digits add to the number that we are dividing by. So 26 divided by 8 in base 9 is going to give us 3 in base 9. Another example of this would be if we are working in base 6 and we have 32 base 6 divided by 5 in base 6. 3 plus 2 equals 5, which is the same as our base 6 minus 1. So we know that 32 is going to be divisible by 5 in base 6. And that is going to give us an answer of 4 in base 6. So again, the divisibility rule for this one, a number is divisible by the base minus 1 if the digits will add to the base minus 1. But again, this only works up to 10. So we just have a couple more rules to go through. Our next rule is any number that ends in a multiple of of x in bases that are multiples of x, they're going to be divisible by x. This one's a little more confusing, so we'll work through it. So we have any number that ends in a multiple of x in bases that are multiple of x. Are going to be divisible by x. Okay, so let's start by just saying that x equals 7 in this situation. So any number that ends in a multiple of x. So a multiple of 7 is going to be 7, or let's use a different x. Let's say our x is 3. So multiples of x, and the multiples of x are only going to be 1 through 9, right? Because in this situation, that multiple is just going to be a single digit because it would be in the ones place. So we have our multiples of 3 are going to be 0, 3, 6, or 9. So any number that ends in 0, 3, 6, or 9 in bases that are multiples of x, so the base would also have to be 0, 3, 6, or 9, are going to be divisible by x. So that they'll be divisible by either 0, 3, 6, or 9. So if we look at an example of this, let's say we have let's say we have 20 in base 6 or base 3. And we want to divide that by, no, we have 20 in base 6, and we want to divide it by 3 in base 6. Right away we know that because we are working in a base that's a multiple of 3, and we're dividing by a multiple of 3, that this number, because it ends in a multiple of 3, is going to be divisible by 3. Okay, so if we have 20 divided by 3 in base 6, we know that's 4 base 6. And it comes out evenly, we know, because we have multiple of 3 as our ones place, multiple of 3 as our base, and multiple of 3 as what we are dividing by. Let's look at another one. So base 9, if we're working in base 9, and we're dividing by 6, so let's say we have 33 base 9, and we're dividing by 6 in base 9, we see first that our ones place has a multiple of 3, our base is a multiple of 3, and we're dividing by a multiple of 3. So we know right away that 33 is definitely going to be divisible by 6 in base 9. And we know that that answer is going to be 5 in base 9. So again, if we go back to our original rule for divisibility, any number that ends in a multiple of x for 1 through 9 in bases that are multiples of x, they are going to be divisible by x. So maybe let's look at this again with another x value. Let's say that x was equal to 4. So our multiples of x are going to be 0, 4, and 8. So if we look at 24 in base 8, and we're dividing that by 4 in base 8, we see that we have a multiple of 4 here in our ones place, multiple of 4 in our base, and a multiple of 4 in what we are dividing by. And we know that 24 divided by 4 in base 8 is going to give us 5 in base 8. Okay, so that's going to be a big trick that you can use for divisibility in other bases. Okay, so that was our last rule for divisibility results in other bases. If you can remember, we had 4 main rules that we talked about. First was that every number in any base is going to be divisible by 1. Any even number in even bases are going to be divisible by 2. A number is divisible by the base minus 1 if the digits add to the base minus 1 up to 10. And then that last one that we talked about, any number that ends in a multiple of x in bases that are multiples of x are going to be divisible by x.